Good afternoon. Now we have second lecture, that is on properties of determinant. So we have 7 properties. First property, the value of the determinant remains unchanged if its rows turn into columns and columns into rows. So when we will convert rows into column, then that is known as transpose. So that is known as transpose actually. So now we have this matrix. So if we will calculate the value of the matrix 15 minus 28, so it comes minus 13. Now we will change rows into columns and columns into rows. So we have 3, 4, 3, 7. We have as 3, 7 means this 3, 7 we have column. We have converted it into rows. And then we have 4, 5 second column. We will convert it into second rows. And then we will calculate the value of the determinant. So we have same 3 into 5 minus 7 into 4. So value is again minus 13. So if we will change rows into column and column into rows, then my value of determinant will not be changed. Then second property of the determinant, then we have if two rows or columns are interchanged, then the value of the determinant changes its sign. Means we can have this matrix value we have minus 13. Now we will change row 1 and 2 interchanged. So we can see we have 7, 5. This will be first row. Now here we have this as second row and we have changed it to first. So first becomes second and the value you can see 7 into 4 minus 3 into 5, that is plus 13. Plus 13. Now if we will change the column column numbers, so we have second column we will write first and then first we will write second. And then we will calculate the value. So we have 5 into 2 15 minus 7 into 4 28. Then we have minus 30. So if we will change it twice, means we have once we have changed one rows and then we have changed columns. So we have 2 times minus. So we have this minus into minus 1. So plus 13 again minus 1. So minus 13. If you change it twice, then value will remain as it is. That is minus 13 only. You can see this. So here we have calculated that value. So here we have considered only change of columns 4, 5 and 3, 7. And we will get this value that is equal to 13. So we have changed one only. Now if we will change rows also, then we have this value 2 times minus. Once minus here, once minus here. So it will be again remains same. So if we will change one column, one row, then twice minus becomes plus. Then property third, if any two rows or columns are identical, then the value of the determinant is 0. So we can have here, we have both 3, 4, 3, 4, then it becomes 0. So any two rows or columns, you have same here you can see we have 2 rows 3, 4 and 3, 4 and then we will get value as 0. So if we will go to 2 columns similar, if I will write this as 4, 3 and then 4, 3, then we have 0 again. If we will go 6, 7 and then go 6, 7, then also we have 0. So that is if identical column, then value is 0. Then property number 4. If each element of row or column of determinant is multiplied by a constant k, then the value of the new determinant is k times the value of the given determinant. Now we have same determinant. I have considered minus 13 and now we will multiply each element of row 1 by 5 means I will multiply this 3 into 5, so it will be 15, and 4 into 5, it will be 20. Then my matrix will be 15, 20, 7, 5. So you can have 15, 20, 7, 5. And if I will calculate value of this, then we have multiplication of this 15 into 5 and minus 20 into 7. Then you can have 15 into 5 minus 20 into 7 minus 65. So you can see by how much, by which value you have multiplied this row elements. So we have multiplied by 5. And then you can have, so we have this as minus 13. So we have 5 into minus 13. And so we have minus 65. So you can see this. If each element of row or column of determinant is multiply constant k. So we have considered this value 5. Then the value of the new determinant is k times. So it will be 5 times the value of the given determinant. Given determinant value is minus 35 and k we have 5. So it will be minus 65, which we got over here. Then we have property 5. If each element of row or column is expressed as the sum of two numbers, then the determinant can be expressed as sum of two determinant. So now you can see this. And the same we have, that is 3 into 5. So we have 3 into 5 minus 7 into 8. So we have this will be minus 14 because 15 minus 56. So 5, 1, 1, 4. It comes minus 1. So now we will express this as sum as two numbers. So I will write it as 1 plus 2. And then I will write it as 3 plus 5. So I have changed here. You can see if each element of row or column is expressed as sum of two numbers. So we have mentioned 3 as 1 plus 2 and 8 as 3 plus 5. Other row will be as it is. Then we will separate out it. So we have 1, 3, 7, 5. So we have this will be first we have taken 1, 3, 7, 5 will be as it is. Now in second we have 2, 5. This will be as it is 7, 5. So you can have plus 2, 5, 7, 5. And then we will calculate determinant of this. So we have 1 into 5. So we have 1 into 5 minus 3 into 7 minus 3 into 7. Then plus we have 2 into 5 minus 5 into 7. So we have 1 into 5. This will be 5 minus 21. So it comes minus 16 and 10 minus 35. It comes minus 25. And then we will get this value as minus 16 minus 25 equal to minus 41. Then go to property 6. If each element of a determinant above or below it, the diagonal is 0, then the value of the determinant is the product of its diagonal. So you can see this. So I have this as 0. Then what will happen? So we have only 3 into 5. This becomes 0. So we have only multiplication of this diagonal, which will be 15. Now if you have 3 by 3 matrix, if we will say we have 1, 0, 0. So if each element of a determinant above or below the diagonal is 0. So let us we have above the diagonal is 0, 2, 4, 3. Sorry, this is now 0 because this is above the diagonal. And then we have 5, 6, 3. Now second and third term become 0 because we have 0. So we have only first term. So what we will get 4 into multiply this 3. 4 into 3 minus 6 into 0. And then we have this as 12 minus 6, 6. So this will be 6. So you can see, sorry, 6 minus this will be equal to 12 minus 0, which will be 12. And you can see 1 into 4, 4 into 3, 12. So you may have lower triangle 0, or you may have upper triangle 0. So we can have this 2, 6, 8, 3. Now this is 0. So we have lower. Now we have 0. So we have this 0. We have this 0. 4, 3, 2. Now what will be value? 2 4s are 8. 8 2s are 16. It should be 16. Now we will check it. We have 2 into we have 8 minus 0. So into 4 into 2 minus 3 into 0. Minus we have 6 into. Now this goes over there. So 0 into 2 minus 3 into 0. 0 into 2 minus 3 into 0. And then last plus 8. So now we have this plus 8. 0 minus 4 into 0. And then this becomes 0. And then this also becomes 0. And therefore we have, again this is 0. So we have 4 2s are 8 and 8 2s are 16. You can see here 16. So if lower or upper triangle is 0, then we have to multiply only diagonal elements to get the value of the determinant. So these are the 6 properties of the determinant I mentioned in the start 7, but we have 6 only. So we will stop over here. Subscribe the channel. Thank you.